Okay guys, welcome back again. In today's video we are going to look at question 8 from November 2020 past exam. Okay, the question is from calculus grade 12 and the focus is on cubic functions. Okay, so this is the question 8. You can see you have 5 questions to solve and the total is 15 marks. Okay, you can see that. Okay, let's get started on the next slide. Okay, question 8. Let's get the question. This is the question 8 from November 2020. Okay, so this is the question. Okay, question 8. The graph of g of x is equal to ax cubed plus bx squared plus cx, a cubic function having a y-intercept of 0, is drawn below. The x coordinate of the turning point of g are -1 and 2. So this is the graph of g, which is a cubic function. You can see it's got the y-intercept of 0. There it is. You can see the y-intercept. The cubic function is cutting the y-axis at 0. Okay, and the x coordinate of the turning point are -1 and 2. So this is a turning point and there is another turning point. The x coordinate are -1 and 2. Okay, so 8.1, the question says, for which values of x will g increase? For which values of x will g increase? This is your g, you can see. This question is 2 marks. So the question says, for which values of x will g increase? You can see the values of x for which g is increasing is only from -1 and 2. Can you see that? You can see from -1 to 2 as you move from the negative x-axis to the positive x-axis. You can see this is the only part which is increasing. It's going up. This part you can see as you move from the negative x-axis to the positive x-axis. This is the part which is increasing because it's going up, and this part is going down, so this part is decreasing. Also this part is going down, so this part is decreasing. So the only part which is going up, and that is the part which is increasing, is this one. So from -1 to 2. And the answer is, for which values of x will g increase? You can see that on the graph. So it will be from -1 to 2. So you can write it like this: x greater than -1, x less than 2. So in the interval from -1 to 2, g is increasing. You can see that from -1 to 2, g is increasing. Okay, or you can also write the answer in interval notation like this, having the round bracket around. So you can see -1 to 2. So you have your round bracket. So the graph of g is increasing on this interval. So you can give your answer like this or like this. Now let's move on to the next question, which is 8.2. So 8.2, what is the question saying? Write down the x coordinate of the point of inflection of g. This question is 2 marks. You need to write down the x coordinate of the point of inflection of g. The question is 2 marks. Okay, first of all, you have to know what is a point of inflection. Okay, a point of inflection is the point on the graph or on the function where the graph is changing the concavity. So you can see when you look at this graph, the graph of g, the graph is concave up on this part. So the graph is concave up, and after that the graph is concave down. You can see the graph is looking down. So from concave up to concave down, there is a point somewhere there where the change is happening. So at that point, the point is called the point of inflection. That's where there is a change in concavity. That point will be somewhere there. Okay, the change in concavity will be obtained in between these 2 points, the x coordinate of the turning point from -1 to 2. So the point of inflection, the x coordinate, is halfway in between the 2 points. So don't make the mistake and say the change in concavity is happening at 0 there. No, you have to find it. It's somewhere there. Probably it's after 0. We are going to see that. So you are going to find it by taking this plus this, you divide by 2, because the point of inflection is in between, is halfway between the x coordinate of the turning point. Okay, and again, remember, the point of inflection is the point where the graph is changing the concavity. So from concave up to concave down, there is a point where the graph is changing in concavity. Okay, so to get the x coordinate of the point of inflection, it will be x is equal to, you take this -1 plus 2, and then you divide by 2, and this will give you, you have 2 minus 1, which is 1, so the answer is 1 over 2, like this, 1 over 2. So you use -1 and 2 because the x coordinate of the point of inflection is in between the 2 points. Okay, so this is how you find the x coordinate of the point of inflection. Now let's move on to the next question, 8.3. 8.3, what is the question saying? The question says, for which values of x will g be concave down? This question is 2 marks. For which values of x will g be concave down? So the concave down is only happening this side. You can see this part is concave down, it's looking down. So the change in concavity is taking place at the point of inflection. So it's somewhere there, right? If you can predict it, it's somewhere there, and its x coordinate will be there after 0. We found it, which is 1 over 2. So this is 0.5. You can see it's after 0. 1 over 2 is 0.5. It's after 0. Okay. So the change in concavity is taking place at 0.5 or 1 over 2 and then all the way to infinity. So don't say that the change in concavity is taking place from 0 all the way to infinity. You just saw that the x coordinate of the point of inflection is 1 over 2. So 1 over 2 is after 0. So that way there is a change in concavity. So at 0.5 all the way to positive infinity. So you can write this as x greater than 1 over 2. So all the values greater than 1 over 2 going that way. So that's where the graph is what? Concave down. You can see it's concave down. This graph still continue. You can see it's still continue. So it's from 1 over 2 to positive infinity. But before 1 over 2, you can see the graph is concave up. Okay. So for which values of x will g be concave down? X greater than 1 over 2. Okay. And you can also write this in interval notation like this if you want. 1 over 2 to positive infinity. So you can give your answer like this or like this. Okay. Now let's move on to the next question. Let me put a line here. Okay. And let me do this. I'm going to do 8.4 here. And what is the question? The question says if g prime x is equal to negative 6x squared plus 6x plus 12, determine the equation of g. This question is 4 marks. Okay. So you are given g prime x. This is g prime x. And the question is asking you to determine the equation of g. Okay. So let's write down g prime x. This is g prime x. You are given it negative 6x squared plus 6x plus 12. You need to determine what? G of x. Right? So g prime x was obtained by taking the derivative of g. Now we want to find what g is. Okay, we are given the derivative of g. We need to find what g is. Okay, let's see that. So you know in the question you can see you are told that the graph of g of x is equal to ax cubed plus bx squared plus cx. So let's write it down. G of x is equal to ax cubed plus bx squared plus cx. You can see you are given it. So this is what they're asking you to find. But you have your a, b, and c. You actually need to find your a, b, and c, and then plug in there, and you have solved the question. Okay, so this is g of x. If we want to find g prime x from this, what are you going to do according to the rules of differentiation? So g prime x from g of x will be 3, that exponent times the coefficient, which is a. It will be 3a x squared, right? So you take minus 1 from the exponent. You carry on. It will be plus. You take that exponent times that coefficient, which is b. It will be 2b x, right? x to the power of 2 minus 1, so this is 1, and then you carry on plus, there is a power of 1 on x, so you take 1 times c, it's c, and then times x to the power of what? 1 minus 1. So there is a 1 there, and then you subtract 1, so it will be x to the power of 0, because 1 minus 1 is 0. So x to the power of 0 is 1, and then you have 1 times c, you have now c. Okay, so this is g prime of x, and you have it there. Now you can compare the two and find your a, b, and c. Can you do that? Can you see you have x squared there and x squared there? So if you have x squared there and x squared there, that means the coefficients are equal to each other. So 3a is equal to negative 6. And what is a? You divide by 3 on both sides. So when you divide by 3 on this side, you get a is equal to, you divide by 3 on this side, you have negative 2. Okay. You carry on, you compare the two, g prime x, this one and this one. Now you have this one. You can see you have x there and you have x there. So since you have x there and x there, it means that the coefficients are equal to each other. So 2b is equal to 6. You can see that. And if you want to find for b, you divide by 2 on both sides. You divide by 2, you have b is equal to 3. Okay. And you carry on, you compare the two. You have c there, which is a constant. And you have a constant there. So c is equal to 12. Okay. C is equal to 12. Now you have your a, b, and c. So you can get your a, b, and c, plug in there, and you have g. Okay. So g of x is equal to ax cubed. What is a? A is negative 2. Plus bx squared. What is b? B is 3. So it's plus 3x squared, right? And then plus cx. What is c? C is 12. So it is plus 12x. Okay. So this is g of x. You have solved the question 8.4. This is what they're asking you to do. Okay. So let's move on to the next slide and do question 8.5. And now 8.5. Let's get the question again. Question 8 from November 2020. Okay. So this is the question. What is the question saying? Determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form y is equal to mx plus c. So you need to determine the equation of the tangent to G. This is G, and that tangent must have what? A maximum gradient. And write your answer in the form y is equal to mx plus c. The question is 5 marks. Okay, so what they want you to do is to write the equation of the tangent in the form y is equal to mx plus c, right? Let's have it down. Okay, so if you know your calculus, you have to understand that g prime x, when you take the derivative of g, this is g, right? But if you take the derivative of g, this g prime x is equal to the gradient, which is m, the gradient of the tangent that is touching g. Okay, so you take g prime x will give you the gradient, and the gradient is the gradient of the tangent which is touching g. Okay, so I hope you understand what I mean. Okay, let's see from the previous question, g prime of x is equal to this. You got this from the previous question in 8.4. So this is equal to m, the gradient of the tangent that is touching g. I hope you understand that. So if you have a tangent touching this graph of g, and if you take g prime of x, this g prime of x is equal to the gradient of the tangent. So this is the equation of the tangent, and the gradient is m. So m is equal to g prime x, and g prime x is equal to this. We found it in the previous question. It was given actually. Okay, so from here, what they want you to do is to have a maximum gradient. So to have a maximum gradient, you are going to take the derivative of the gradient. So you take the derivative again. So it will be the second derivative, right? So you take the derivative of this, okay? And you equate it to 0, and then you solve for x. So that value of x will give you a maximum gradient, okay? Let's solve and find the x value, which will give us a maximum gradient. Once we found the x value, we are going to plug it inside here, and then we are going to have the maximum gradient. So first of all, you need to take the derivative. So the derivative is equal to, you take 2 times negative 6, it's negative 12, x to the power of 2 minus 1, so it's 1, and then plus 1 times 6, it's 6, times x to the power of 1 minus 1, which is 0, so x to the power of 0 is 1, times 6, it's 6, and this gives you 0. This is a constant. When you take the derivative, you get 0. Okay, now from here, you are going to equate it to 0 and solve for x. So the x value is the x value which will give you a maximum gradient. Okay, so let's solve for x. So you have this, you make it equal to 0, and you solve for x. So the x value is the value that will give you a maximum gradient. Okay, so let's solve for x. So you have negative 12x is equal to negative 6, right? And to solve for x, you need to divide by negative 12 on both sides. So you divide by negative 12 this side and by negative 12 this side. And this cancel with this, okay? So x is equal to, this is 1 over 2, right? So this is the x value that will give you a maximum gradient. This is how you get the x value that will give you a maximum gradient, okay? So let's plug in there and know what the maximum gradient is. So m is equal to this, you plug in the value of x, which will give you a maximum gradient. So you have m is equal to negative 6x squared. So you plug 1 over 2 in the place of x. Wherever you have x, you plug 1 over 2. So it's like this. Remember, squared plus 6x. So 6. You plug 1 over 2 and then plus 12. So what is the maximum gradient? Use your calculator. Okay. So you have negative 6. And in bracket, you have 1 over 2 squared. And then plus 6 times 1 over 2 in bracket. And then plus 12. So this is equal to 27 over 2. Okay. So the maximum gradient is 27 over 2. Okay. So the gradient is equal to 27 over 2. Or you can write it as a decimal, 13.5. Okay. So this is the maximum gradient, the one they're asking you to have. Okay. So we found it by first taking the derivative of the gradient, right? And then we make it equal to 0. And then you solve for the x value. When you get the x value, you plug in there to know what the maximum gradient is. Okay, so this is the maximum gradient. Now let's carry on and have what? The equation of the tangent. Okay, so the equation of the tangent is to be written in this form. So y is equal to mx. What is m? 27 over 2 x plus c. Okay, now you need to find c. Okay, you need to use a point on the tangent to solve for c. Okay, you can use this. You have the x coordinate, right? You can find your y coordinate. So you have to take this and plug in the original equation, the equation of g, and you are going to get the y coordinate. And when you have it, now you can solve for c. Okay, let's do that. So let me make a line here and let me carry over here. So what is g of x? Remember in the previous question, g of x is equal to this. We found it, right? When we were solving for a, b, and c. Remember from the previous question. So g of x is equal to negative 2x cubed plus 3x squared plus 12x. Okay, to find the y coordinate, you are going to take g of what? G of 1 over 2. Okay, and this is equal to, you have negative 2. You plug in 1 over 2 there, right? Cubed, remember that, plus 3x squared. So you plug in there 1 over 2 squared plus 12x. You plug in there 1 over 2. Okay, and so this is your y. I can say y is equal to, use your calculator to find the answer. So what is g? of 1 over 2. It's this. You plug in your calculator, what you have there. Plus 3, 1 over 2, plus 12, you have 1 over 2. So you plug your x inside the original equation so that you can have your y, okay? And so your y is 13 over 2, okay? Your y is 13 over 2. Okay, now from here, you have this point. Can you see? With coordinate 1 over 2 and 13 over 2, right? This is your x coordinate and this is your y coordinate. Remember that the first coordinate is always your x and the second coordinate is always your y. Okay, so this point is a point on the tangent, right? This point is on the tangent. Okay, now you can use this point to solve for c. Okay, let's plug this point in there and solve for c. So this is your y. You plug in there. 13 over 2 is equal to, you have 27 over 2. X, what is your x? 1 over 2, right? This is your x and this is your y. Okay, and then plus c. I hope you can follow. So you have 13 over 2, and then you can simplify this, or you can just leave it like this and take it to the other side. So it will be negative, you have 27 over 2 times this 1 over 2. So I just take it and move it to the other side. And this is equal to c. So you only remain with c on this side. Now to solve for c, what is c equal to? C is equal to, use your calculator. So you have 13 over 2 minus 27 over 2 times 1 over 2, right? So c is equal to negative 1 over 4. Negative 1 over 4, or in decimal. Okay, so you have your c. And finally, what is the equation of the tangent that has got a maximum gradient? It will be y is equal to 27 over 2x plus c. What is c? C is negative 1 over 4. You find it, okay? Or you can write it using decimal. So this is 13.5, right? 13.5x, and this is negative. Okay, so you can give your answer like this or like this. And we are done with question 8 from November 2020. Okay, I hope the explanation is clear. If you find some value in the video, please show that with your likes and comment in the comment section. Okay, and don't forget to subscribe, activate the notification bell so that you can be notified every time I post new content for you. Until next time, I'll talk to you soon.